The topic for Lesson 8.1 is angles of polygons. You'll find the sum of the measures of the interior angles of a polygon and the sum of the measures of the exterior angles of a polygon. How does a scallop shell illustrate the angles of polygons? The scallop shell resembles a 12-sided polygon with diagonals drawn from one of the vertices. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. For example, segment AB is one of the diagonals of this polygon. Polygons with more than 3 sides have diagonals. The polygons below show all the possible diagonals drawn from one vertex. So here is a diagonal of a quadrilateral, 2 from a pentagon, 3 in a hexagon, 4 in a heptagon, and 5 in an octagon. As we draw diagonals, we're breaking up each polygon into triangles. So, a triangle obviously had 3 sides. So the number of triangles you could make would be 1. And we know that there's 180 degrees in each triangle. So 1 times 180, we have 180 degrees. In a quadrilateral, we have 2 triangles. So if there's 4 sides, we have 2 triangles. So 2 times 180, 360 degrees. And the pattern goes on and on. So pentagon, we could make 3 triangles. So 3 times 180, or 540 degrees. Hexagon, we'll make 1 more triangle, 4. So 4 times 180, 720. Heptagon, we'll now have 5 triangles. So 5 times 180, 900. Octagon, we'll have 6 triangles. So 6 times 180. There is a handy relationship between the number of sides and the number of triangles. Write that relationship down in your notes. I hope you gave yourself a little bit of think time to get that relationship, because here it is. If a convex polygon has n sides, S is the sum of the measures of the interior angles, then S equals 180 times the number of triangles is always going to be number of sides minus 2. So for a pentagon, 5 minus 2 is 3. It would make 3 triangles, so 180 times 3 is 540. A decorative window is designed to have the shape of a regular octagon. Find the sum of the measures of the interior angles of the octagon. An octagon has 8 sides, so we're going to take 8 and substitute it in the formula for n. 8 minus 2 is 6. So all we have left to do is multiply, and we get 1080. And now we're going to work the opposite direction. The measure of an interior angle of a regular polygon is 135 degrees. Find the number of sides of the polygon. So we know the sum formula. So if I knew one angle is 135. If only I knew how many angles there were, I'd get the sum of all the angles. So I'm going to have to solve for n. I can distribute the 180. And subtract 180n from both sides. So we have 45. Negative 45 equals negative 360. So if I divide both sides by negative 45, I get n equals 8. And if you wanted to double check, you could substitute 8 back in for n, and we'd have 180 times 8 minus 2 is 6. And when you multiply, we get 1080, which if we wanted to do each angle, and it's regular, so that means they're all the same, we could divide by 8, and sure enough, we get 135. That's just my check. So the actual answer was 8. And we get another way to use that sum of an angles formula. I want us to find the measure of each interior angle. We've got a quadrilateral, so that means it's got 1, 2, 3, 4 sides. So we're going to take 180 times 4 minus 2 is 2. So the sum of a quadrilateral's angles is going to be 360. So for us, we have 360 equals, I'm going to combine terms as we write it down. 11x plus 11x would be 22x. 4 plus 4 is 8. Plus 5x plus 5x is 10x, just to save some writing. So combining likes, I have 360 equals 32x plus 8. And you know what to do. Subtract 8 from both sides. So 352 equals 32x. And of course divided by 32. And we get x equals 11. And the question didn't say find x, it said find the measure of each interior angle. So then we could do measure of angle S is going to equal measure of angle U, because they're both 11x plus 4. If we substitute in the 11, 11 times 11 plus 4, 121 plus 4 is going to be 125. That's an ugly 5. And for the measure of angle R, which is going to be the same as the measure of angle T, because they're both 5x, 5 times 11 is going to be 55. And you could double check, add 125 plus 125 plus 55 plus 55, and you should get 360. And we had an interior angle sum theorem, so theorem 8.2 is the exterior angle sum theorem. If a polygon is convex, so that means you can't connect a line where it goes through the exterior, so something like that would be concave. Okay, so if a polygon is convex, then the sum of the measures of the exterior angles at each vertex is 360. Okay, so we got rid of our concave polygon, and let's just look at these. If we add angle 1 and angle 2 and angle 3 and angle 4 and angle 5, if we could squish that polygon together down to one little point, we end up just going in a circle. That's a terrible example of a circle, but you get the idea. So interior angles will be different given the number of sides of the polygon, but exterior sum is always 360. Find the measure of an exterior angle and an interior angle of a convex regular nonagon. So a nonagon has 9 sides, so since the sum of all of the angles is 360, we're going to take 360 divided by 9 sides, 9 angles. Each exterior angle would be 40. Now there's a special relationship between an exterior angle and the interior angle. They're always going to be supplementary. They form a linear pair. So since we know the exterior angle is 40, to get an interior angle, I could use the formula we had from theorem 8.1, or we could just subtract 180 minus 40, and we get 140 for each interior angle. In summary, if a convex polygon has n sides and the sum of the measures of its interior angles is s, then s equals 180, the number of degrees in a triangle, times n minus 2, how many triangles it would make. The sum of the measures of the exterior angles of a convex polygon is always the same, 360.